Okay, so we will start then. So good afternoon to all of you. Myself, John Jose. I am from Department of Computer Science Engineering, IIT Guwahati, one of the coordinator of the workshop. A warm welcome to the SPARC workshop on blockchain technologies and decentralized environments, organized by the Department of Computer Science Engineering, Indian Institute of Technology, Guwahati, in collaboration with University of Catania, Italy. Some of you have already attended the previous workshops, but we find that there are certain new participants who are new to the SPARC workshop series organized by us. For them, a quick introduction of what is SPARC program all about. SPARC, which is the abbreviation of Scheme for Promotion of Academic and Research Collaboration, aims at improving the research ecosystem of India's higher educational institutions by facilitating academic and research collaborations between Indian institutions and leading universities of the world in the areas that are at the cutting edge of science or with direct social relevance to the mankind, specifically in the Indian context. The strong joint research evolved out of SPARC initiative should lead to tangible result that should include a large number of high quality research publications, solution to key national and international problems, development of new coursewares, research monographs, and imbibing the best practices from top international academicians and researchers, and leading to strong bilateral cooperation and improved world reputation and ranking of Indian institutions. In the year 2019, the then MHRD and the present Ministry of Education sanctioned a SPARC project titled Approximate Computing Techniques for Resource-Constrained Edge Devices. We are extremely thankful to Ministry of Education, Government of India for providing us with this funding opportunity through which we could have a platform for interaction between international academic luminaries, Indian academic and research community. After seeing a huge turnout in the 3 previous workshops, this is the 4th online workshop in this series. In today's workshop on blockchain technologies and decentralized environments, we have with us Dr. Davide Patti from University of Catania, Italy as the resource person. I have attended a few of his talks and tutorials in international conferences of repute, and I have witnessed his amazing clarity in the talks, and he connects well with the audience. Even though he has planned a visit to India as part of the SPARC initiative, but COVID pandemic spoiled all the previous plans. Already, Professor Patti is working with our students in IIT Guwahati, and we have large number of joint publications. We are also working out a plan to arrange his visit to India in the early months of 2022 if the pandemic settles. On behalf of the organizing committee, I propose a hearty welcome to Dr. Davide Patti. And we got an overwhelming response of 250 plus registrations, and we have over 140 confirmed participants who will attend all the sessions. Close to 20 to 25 of them will attend some sessions of their choice. On behalf of the organizing committee, I propose a most heartily welcome to all the participants. We hope that this 6-hour session spanning across 2 days, today and the next Thursday on 28th of July, would be a productive learning session for all of you. Before going into the workshop, few general announcements to the registered participants of the workshop. The same Microsoft Teams link that you used for login today, that is going to be used for the next day as well, and for the second session of today's workshop also. So from 3 o'clock to 6:30 p.m. in the Indian Standard Time, we have a break from 4:30 to 5. During the time also, the Teams link will be on, but if you want, you can log off and re-log in prior to the beginning of the second session. Like already mentioned, for distribution of e-certificates, your attendance should be tracked from the login logout information inside the Teams, as well as there is a attendance feedback form that is shared in your registered email. Kindly fill up the form, and the form will be active from 6:30 p.m. onwards. So form basically contains your login name that you used and how many times of in and out, login and out happened, and an approximate duration of your login. So this form filling is very important as it is linked to our e-certificate generation tool in the backend. For people outside from IIT Guwahati, if you wish to ask queries to Dr. Davide, you can actually fill up the queries form that is shared in the email, and as and when the resource person permit, the coordinators will ask these questions. Those who are having access to the chat box, you can raise your hand, and when the resource person permit, we will unmute you and you can raise your questions as well. And this is possible only for people from within IIT Guwahati. And before beginning, I request my colleague, Dr. T. Venkatesh, who is the joint coordinator of the workshop and associate professor in Department of CS IIT Guwahati, to introduce the speaker. Over to you, Dr. Venkatesh.
Thank you, Dr. John, and a warm, hearty welcome to all the participants for this SPARC workshop. And it is my pleasure to introduce Dr. Davide Patti. Dr. Davide is currently an assistant professor at the Electronics and Computer Engineering Department, University of Catania. He has published several works on design space exploration, low power techniques for embedded systems, and network on chip architectures. He has been teaching several courses in the computer science field, including human computer interaction at the Faculty of Psychology of Korea University, Enna, Italy, and lectures at the University of Southampton, UK. He is a steering committee member of International Workshop of Network on Chip Architectures. He is also associate editor of IEEE Access and guest editor of many special issues. He is co-author of the NOXIM project, currently used by a vast community of researchers working in the area of on-chip communication systems, and employed as an experimental platform in more than 500 scientific papers published in refereed ACM and IEEE international conferences and journals. With this short introduction, I welcome Dr. Davide Patti to deliver his sessions on blockchain technologies. Over to you, Dr. Davide.
Thank you very much. Thank you very much for your introduction. It's really an honor to be here with you in this project, and welcome also to the attendees and the students, etc. So I think I will share my screen now. Okay. I hope that you can see the slides. Okay, so this is some information about me, because anyway, even maybe after the workshop, after everything is ended, you feel free to contact me for any further questions about the topics that I addressed. Okay, so it's if you want, you can establish some kind of discussion with me that extends more than the workshop, and I hope to maybe establish collaboration. So this is only a starting point, and I thank you, the SPARC organizer, for this opportunity. As you can see here, this is my mail, and also you have the link to my GitHub repository, where you can see my projects. Everything is open source, of course, and also my institutional website, etc. So today, this is the outline of the topics. I think that in some point, maybe I will ask you if you have any question, because maybe that at some point it's better to clarify some things. It's a complex topic for some aspects, but at the same time, it's simple, it's strange. And okay, what I want to go directly to the point. I want to directly to the point because blockchain. How many of you have heard about blockchain? I think this is, let's say, a word that is becoming like a buzzword. Okay, it's some magic word that you put in the project just many times just to sound cool, to make your project more appealing, etc., etc. This is a this is a sad destiny that many words have in the computer science fields. Even if the topic is very important, maybe that many people abuse about these words and put just like an enhancement that make no sense, maybe. And in this case of blockchain, the situation is, I think, is even worse that in the let's say in the machine learning case, okay, or in the big data case. Blockchain is absolutely overabused. And what I want to show you in these two meetings is which is the real potential revolutionary impact of the blockchain, okay? Understand when it makes sense, but I will want to explicitly be clear that I want to explain also when it doesn't make sense. The blockchain is one of the topics that you can understand very deeply if you know when it's completely out of purpose, use this kind of technology, okay? It's very important. So I want to make some clarification here before we start discussing about the topics, because we are talking about technology. We are talking about science. We are not talking about speculation, prices, trading, and all this kind of stuff that has been developed by some people around this world, okay? Because remember, and this is one of the key points, the price is the consequence of the technology, is the consequence, is not the origin, is not what created the technology, okay? So when I see something like that, if you see these two graphs on the bottom, you have, like, say, the price of the asset, of the Bitcoin asset in this case. So you can see that the top picks exactly match the number of searches on Google for the blockchain world. This kind of stuff, so that people are interested in something just without knowing anything and searching when the price is going up, is not what we are interested in. Because remember that the real works, the real research happens here before. Not where there is this crazy hype about all the stuff. And this happens every time. It's not the first time for blockchain. If you think about, let's say, if you think about the World Wide Web, okay, beautiful. We have the web application, but we have the web application because of a worldwide internet open TCP protocol, or because the price of the Google and Apple stocks rise, okay? Which is the consequence of which, okay? Okay, I think that this should be clear after this disclaimer. And I want to clarify some terms, because there is sometimes a confusion that people make when talking about blockchain. First of all, when you see the word Bitcoin with a capital B, this is the decentralized protocol. This is what we intend for blockchain. Okay, what we mean with blockchain is the protocol. Okay, is the Bitcoin. Okay, and we will see in the second meeting also other kind of protocols, but this is the main one. When you see the Bitcoin with the lower B or the BTC symbol, okay, this is just the underlying digital asset. Okay, this is exchanged using the protocol. Okay, so there are two different things. Okay, because and this is not my invention. This is the way that you must correctly indicate the things. Okay, if you want to see if someone is not properly understanding it, the topic is when they confuse the Bitcoin as the asset with the Bitcoin as the protocol, and we will see the differences. Which are the goals of this workshop? The first, so I think that in the end of the workshop, you will see these 2 points and you will say, okay, now I understand what was written here, okay? The first point is understanding that a blockchain is an open and decentralized platform of trust. Open, decentralized platform of trust, okay? Is not a distributed database, okay? If you want a database, use the database. Beautiful databases, many beautiful databases we have. And I see a lot of discussion when people talk about distributed ledgers. Okay, this is the distributed part. The things that information is distributed is not the main point about blockchain. Okay, as we will see. The second point is understanding that the digital asset, in this case, for example, for the Bitcoin protocol, the BTC, the Bitcoin that people exchange, the money, okay, into words you can say the money, are only a first application of this trusted digital reality that we created, a layer one, okay? I cannot anticipate too much at this point, but imagine if the purpose of internet, for example, you use the web, you have beautiful website, okay, web application, etc. This is the web at this level. Of course, the web, to discuss, let's say, to ask pages to another web server in another place here, must exchange packets, okay? The packets go at the IP level, okay? The packets of the internet, and they assembled to create the page. So, but I don't care about this. I just connect my application. I connect, for example, for Instagram. I don't know. I want to make an example that Instagram, Twitter, the web page of your favorite journal. I don't know. You assemble this web page, but what happens under the hood is that a set of packets go through the servers of internet. Okay. Now imagine that the Bitcoin, the asset, are like the packets, okay? So it's like we are in a stage where we are discussing about the packets. We are not discussing about the application of the blockchain. We are starting discussing about the blockchain. We will see an example of layer 2 and layer 3. But remember, this is not the final purpose. The final purpose of internet, what the people love, what the industry use, it's not to exchange packets. It's to exchange the higher level information here, not exchange the packet, okay? Okay, we can move on. Okay, let's start from an expression down to the rabbit hole. Okay, being interested in the blockchain, we will call it, topic is defined sometimes like going to down to the rabbit hole, because it's like you have this surface, okay, very hard surface, and you try to go inside and you say, hey, what is this all about? What this is blockchain stuff? And every time you get rejected, like you don't understand, you say, okay, this is nerd money. This is something for criminals. This is something strange. This is an underground phenomenon. Many people, the first time, and even me, I am in the topic since 2013, okay? So it's 8 years now. But in the first time you get in touch with this topic, it's like very difficult, because you see only the surface and it seems something very scary or strange, or simply something that you shouldn't care about. But when you enter this hole, you will discover that there is a set of concepts, simple concepts that interact with each other. And it's like you never stop learning, because everything that you learn about, read about, then you have another things that, like a puzzle, is related to. So many people, and this is what I show here in this graph, many people go into the rabbit hole, being involved in the blockchain topics, starting from very different fields. Maybe people, some people are interested in cryptography, okay, and they start being interested from the cryptography point of view, and then discover that there is a big relation with game theory, with monetary theory, with network and distributed system. But other people, we start from maybe other of these squares, okay? So these people then in the community that you meet another people and say, how do you discover the blockchain topic, etc. Oh, yeah, I am an economist. Oh, I am an economist. I am a computer scientist. Oh, I am a cryptographer. I am expert of game theory. And this is very interesting because there is a very heterogeneous contamination of cultures, and this is very, very, very interesting and fascinating. So now I want to be clear from the start, and it's time to reveal the truth. A blockchain, it's a chain of blocks. Okay. I know that many people of you maybe will be disappointed. I know that many people of you will be very surprised of this incredible discovery. Maybe someone will not sleep tonight thinking about this disrupting truth, okay? But this is all I can say to you. But what I want to say here is that this is just to say that blockchain means nothing if you live in this way, because many questions remain open. If you say blockchain, okay, and you say, okay, but what are these blocks? How are they chained? Okay, why are they chained? What's inside the blocks? Okay, why don't we put everything into a single block? Okay, the chaining, it's something that happened or it is something that is in progress. How it started, how it can stop, who chained this block? As you can see, this definition, it's just create more question that the topic that clarifies. Okay, someone can just say, okay, I'm not scared about all this question because I started computer science 27 years ago, and I know what a linked list is. Okay, because you can see also in this way, a linked list, you just have something and you just say, okay, I have blocks, I think they are connected. I think there should be some kind of linked list. Okay. Okay, this is just to say that we have to use this term, but the term answering to the question that this term creates, okay, it's understanding the blockchain, okay, because it's not a good term. It's something that doesn't really clarify which is the main point. I always, this is something that I have in my mind, and maybe make no sense, but maybe you will agree later that this, saying something like, okay, Bitcoin is a blockchain-based technology. You always hear this kind of, I don't know if you go to meetings, to projects, you say is a blockchain-based technology. It's like saying, okay, humanity is a skeleton-based biotechnology, okay? It's only a very narrow perspective of the topic, okay? So it's not a good term from this point of view, okay? Okay, maybe with this slide I will win the prize for the most scary slides in the workshop, but let's go on. What really makes you understand which are what is a blockchain, and we must use this term, okay? So we know the problems of this term, okay, but we must use some term, and so I will use blockchain as term, okay, because we must choose something. And this is the most commonly accepted, okay? And so you cannot understand what blockchain is without understanding the Bitcoin, the vision, the perspective of Bitcoin, because Bitcoin with a capital B, as you can see. And this is like, because Bitcoin is what invented the blockchain. The blockchain, the first time that we start having a blockchain, it's on the 3rd January 2009, okay, when the Genesis block has been mined, okay. This is when the blockchain was born, okay. We have a precise date, the 3rd January of 2009, And this is where all started. Okay, so if you don't understand how Bitcoin was born, you don't understand and works, you don't understand how blockchain works. And then you have some little understanding of some mathematical concepts that make it possible, which are the hash function, high symmetric cryptography, and some other topics. I will try to be okay, maybe for some of you will be something that you already know, but for some others will be something new. So I will try to be technical, but not too much technical about this topic, because I know that some people can just lost the track when discussing this of something like that. What I'm interested in is just to get the idea, okay, behind this concept. Okay, so I think it's time to start with the first topic, which is the discussion about what is the difference between physical and digital assets. Okay, I think that we can start from a question which will be our main question, and this question is, the central point is, it is possible to exchange or transfer in general something that is purely digital, something I want to be let's say as more generic as possible, as you can see. Okay, I don't want to say I want to transfer, I want to do something that is purely digital, maybe some digital good, an image, an asset, a file, some form of money. Okay, why not? So whatever maybe that has a value for you. Okay, you say this is good, I want to give as a gift to you, I want to give to you this is digital, I give to you. Okay, this leads directly to the double spending problem, which is our first topic. When you have something digital content and you want to, okay, I give this to you, I want to send to you, what you actually do, let's see Bob here on the left that has some digital value, something, okay, maybe an image, I don't know, maybe a text, I don't know, and wants to send to Lisa that you see on the upper side. What happens is that, okay, what happens is that actually Bob doesn't send in the physical terms to Lisa, because can send also a copy to Alice. What I'm saying, what I'm telling you is that when we use the term send, okay, in our computers, for example, I sent you an email, I sent you an image. What actually happens is not that we send, is that we make a copy, okay, and give a copy to you. Okay, we don't send. If I send a letter and I write in the paper a letter to you with a pen, and I send a letter to you, okay, a mail. But if I send an electronic mail, I send a copy. I still have the copy on my computer. When I send an image, I don't send you an image. I just copy an image and give it to you. So the double spending problem is the chance to being able to use the same asset at different times. Okay, you send it to one, you can send it to another. And this is a problem if we want to answer to the first question before, because we want to give a value to someone. What is the reason for this difference? The reason is that is the difference between information, which is in the digital world, we are discussing about information, and physical assets. Okay, information in particular never represents the state of the world directly. What I mean, if you have a physical apple, you have that apple, but okay, and of course, if I give you that apple, okay, what happens? Happens that since in the physical realm, when I move that apple from A to B, I give you that apple, okay, the apple is composite of atoms, okay? So if I give an apple to you, the atoms that were in this point are translated in the other point. You now have the atoms that compose the apple. If I have a computer file with a beautiful image of an apple, I can never transfer this, okay? I can never transfer this. I can only copy. And this is a big problem. So this is it's also a big feature of the information. Information, if you can read the information, of course, you can also copy perfectly, okay? So there is no difference between copying and reading, okay? There is no handover of information. You cannot say, okay, I have this information and this information moves from this point to that other point, okay? Doesn't happen something like that, okay? And digital information, digital asset, have this property, okay? Can only be spread like ideas. Sometimes someone will say there's a beautiful quote that I like very much. That is, if you have an apple and I have an apple, and we swap apple, in the end, each one will have one apple, okay? But if you have an idea and I have an idea and we swap ideas, in the end, we have each two ideas, okay? I think this is perfectly the match the point about the difference between physical asset and information-based asset, okay? Then, of course, in theory, it's possible to make double spending even in the digital world, in the physical world, okay? But it's something that it really doesn't happen, okay? It's not that happen. It's just that you promise to someone that you will give that asset, but in the end you cannot give to two persons the same asset, okay? Okay, this is a photo from a beautiful film where there is Italian film where there is but this is subtitled in English if you want to see. But it's someone. This is Toto. Here is the main character that sell the historical Fontana di Trevi, which is in Rome. It's a historical, very historical fountain, and it sends the fountain to several people in Rome, like it was his own fountain, okay, and sell to different people. I say, okay, I sold you this fountain, okay. So it's something, doing something like that is not really physical double spending. It's just a scam, okay. Anyway, instead, the information-based world, will be a real, okay, you really do the double spending because two people have the same image, for example. Now, to understand how we can solve this problem, I think that we have to make a short overview of the how the value has been exchanged in human history, because if you do that, we can understand which are the main properties, okay, that solving our problem must address, okay? So we want to remember that our topic is always this answering to this question, okay? So if we want to transfer something that is purely digital, avoiding the double spending. And so if we understand how the value has been exchanged in the human history, maybe that we can catch some of the properties that our solution should have, okay? So what is the most simple and typical transfer of value that we have experienced every day? I will start from this just because it's the simplest that we have experienced, is the transfer of money, okay? If Bob has this $10 bill and okay wants to give this $10 bill to Lisa, just give this bill to Lisa. Okay, it's a physical transfer, and Lisa can answer by giving the books. I don't know. Okay, so Bob cannot give the same $10 bill to Lisa again. Okay, this is how the things work in the traditional world. Okay, but I think that we had to investigate a little more this problem, because okay, we can be inspired by money because money works. But first of all, why there is the money? Because I don't understand why people don't just, since the physical object have this beautiful property, so that if I give you an apple, you have apple. If you give you, I don't know, water, you have water. And why don't we just exchange the goods, okay? The physical objects, since they have this property. This is what is historically known as barter, okay? The direct exchange of goods. This is not done mainly because of three motivations, okay? First, these are three problems. Firstly, the lack of coincidence of scales. We don't have the coincidence of scales. For example, it can happen, it cannot happen, but very often we don't have the coincidence of scales. For example, if I produce shoes and I want to buy a home, okay, for producer of a home, the scale is different. I have to collect and produce a lot of shoes to pay for one home, okay? And maybe that the one that is selling the home don't want so much shoes, okay, for this home, okay? Maybe, I don't know, thousands of shoes for buying a small home, okay? I'm sure that you know someone that would accept thousands of shoes, but in a general case, there is a problem of scales, okay? The other is the coincidence of time frames, okay? So the timing is different. You want to buy a car, but you produce fish. And so you accumulate the fish because the fish is what you produce. And you say, okay, when I have 2,000 fish, I will give to the car seller. But what happens in the meanwhile? What happens is that maybe it's not a good idea, because maybe the fish of 1 month ago are not so valuable, and so there is a coincidence of time frames. Another is the third one problem is the coincidence of locations. I want to buy a house, okay, and I want to pay. I want to buy a new house, paying with another house, with my house, okay. Okay, but so there is no problem of coincidence of scales. There is no problem of coincidence of frames, of course. The problem is that I cannot go around with my home, with my house, okay, telling, hey, do you want this house? I give it to you, okay? No, if I sell my house to another one having a house, I must go to his house to live in their country, and he, her, must go to the place where I live, okay? So we are forced to also exchange the location, which is not what we wanted. We just want to change the house, not to change the location in which we live. So the problem is that I cannot go around with my house, okay? Okay, given these three problems, of course, we need something that act like we need something so that our effort in the production, we produce, people produce different things, okay? Okay, so I make different colors to make the idea. These produce this kind of stuff, yellow stuff. These other people produce red stuff, other kind of stuff. People produce services, different kind of things. In the end of the story, all this stuff which is very different from people to people. I have a beautiful colors here. As you can see, all of them in the end can be converted in some exchange medium, okay? Something that acts as a medium where I can store my effort in producing the different kind of stuff, okay? We need something to implement an indirect exchange. I'm sure that you heard this word before, because this is money. Money is the first example of indirect exchange, okay? And also money is, it's also one of the first experience that you have in the life. Imagine the kids, okay? I don't know if you have seen recently, in general, the kids, even in the kindergarten, when they are very small, the kids, they exchange cards, they exchange little crystal balls. It's a natural experience for the human being to find something. There is an exchange of value, okay? So money is not a strange thing. It's a natural disposition of the human being, finding something and use this as a medium of exchange, okay? Everyone has invented some kind of money when was young, a child. The problem is when you invent money and you are an adult, okay? Then start the problems. Okay, so let's see, since we have understood that money is what solves the problem in our society, okay, and allows the exchange of value, and we want to answer to the first question, let's see what property has the money. So let's see if we can create digitally the same stuff, okay? This is our purpose, okay? Answering to the first question, looking at what is good for money. Money, of course, has evolved from many thousands of years, and in different cultures, there were different objects used as money, okay, shells, I don't know, depending on the different culture. When the people were separated, where the different communities were very separated to each other, maybe that some kind of people lived in island that were very distant from other islands, okay, they used their own shells and their own objects, okay? So, for example, shells from some kind of place, okay? The problem was when other people from other country, maybe, just giving a random example, came to the island that was very isolated and say, hey, imagine that you discover that these shells are used as money in some remote island, okay? And you go there and you say that people collect this kind of shells and use as money. And imagine that from the country that you come from, before going there, you know that there are a lot of these shells. It's not something that is so rare. So the next time that you go there and you bring a lot of shells and you start buying things in this island. What happens is that you devaluate the value of the shells that the people have there, okay? Because they see a lot of shells and the value of these shells becomes less, okay? What happened in the last 2 centuries is in the last few centuries is that in the end of the story, since the shells, the stones, this kind of stuff is very specific of the different countries, what happened is that the gold has been adopted as a standard, because it's like that less or more the gold is more distributed around the world, okay? And it's not like a kind of shell that is only in one place, okay? And as some property, it's difficult to break, can resist to, okay. So what happened is that the store of value until some years ago was the the gold, okay? So let's see what, from the examples that we have seen, which are the properties that a good money, a good store of value must have, okay? Remember that we want to see these properties because we want to understand how it's possible to replicate in the digital world, okay? What makes good money is, it's like the opposite of the problems that we have seen before. First, is durable, okay? Don't perish with the time, okay? $1, one piece of gold, in the next month will be the same, okay? Will not be destroyed. Portable, it's easy to transport, okay? Okay, so I can carry the cash with me, okay, depending on amount of cash. But in general, these are properties which are not Boolean. It's not on, off, okay? It's not or on or off. It's maybe like less or more of each of these properties, okay? The third property is that is fungible, okay? What does it mean being fungible? Fungible means that if I give you, let's say, $1, okay, $10, okay, $10, okay. If I give you $10, and then I say to you, hey, please return me $10 tomorrow, okay? Then tomorrow, okay, let's say $10. Tomorrow, it's not that tomorrow I want exactly that $10 bill. I want any other $10 bill, or maybe I want $5 plus $5, okay? Fungible means that each piece, it's the same of the other, okay? Okay, I don't, when I give to someone, I don't need exactly that one to be returned. I can use another, okay? Third, fourth is the variable. It's easy to check the authenticity. It must be easy to understand if some kind of money is true or has been falsified. Okay. Third, the fifth point is the divisibility. Okay. Remember that these are not on-off property. It's not true or false. It's from 0 to, I don't know, perfect, okay? Divisible, okay? It's possible to divide, okay, in small amounts. Let's say, if I have diamonds, okay, and I wanted to buy, I don't know, a small slice of pizza, using diamonds, I have the problem of creating a very small diamond. I don't know how little could be, how small could be a diamond to pay a slice of pizza. Okay, so it's a problem, the divisibility for some kind of stuff. Okay, okay, and also, and this is very important, scarcity. Okay. It's not about their utility. It's about it should not be easy to produce. Okay, if I want to use something as a store of value, it should not be very easy to produce. Okay, remember the example that I made about the shells of that remote island. When I discovered some place where there were a lot of shells, I went there and say, hey, I have a lot of shells, and the shells were not more suitable for being used as exchange of value. Another example is, okay, I'm sure that the iron, okay, the metal, okay, I think that is very useful as metal. I think that maybe that the iron is more useful than gold. Okay, I'm discussing not about the price. I'm discussing about the utility. Okay, iron is very useful, but cannot be used as a store of value. Why? Because you can produce every year a lot of iron. Okay, you can find a lot of iron. So you cannot use the iron as a store of value. Instead, for example, the gold needs effort. Okay, you need gold mining, and you know that offshore, of course, if you consider the planet, the more you go on mining the gold, the less gold remains. Okay, it's obvious. Okay. Except except if we don't go to Mars, and maybe imagine we go to Mars and we find a big amount of gold, which is let's say 100 times the amount of gold that we have in the Earth. Do you think that the gold will have the same value? I'm not sure about that. Okay. There are any question? Or you can make when we make the prac, okay? Please let me know. Okay, I think we can go on, and maybe you can make a question during the break that we will have. Okay, at this point we have a choice, okay? Or we can just, we have decided that something is useful as money, okay? Some physical thing, okay? Then we have a big choice, which is a crucial point for our digital information. We can exchange directly the physical object, okay? Imagine we have decided about gold coins and we exchange the gold coins, or we exchange shells or something else. Or the opposite, it's to just take a piece of paper and write the amount that each one has, okay? So that if A is someone, okay, has 100 and B has 100, okay, they put this 100 in some place, and then if A wants to give 50 to B, then we can just say, okay, don't just physically move these tokens, just leave where they are. Just write in some piece of paper called the ledger that now A has 50 and B has 150, okay? If we write this, okay, it's like we are moving because we track the actual status. Which is the difference between using a ledger when we annotate the movements and directly exchange the physical tokens? Okay, this is crucial. It's that exchange of tokens is inherently trustless. So if A gives to B the token, the physical token, then the exchange has been done, okay? B can go away with the physical token. The ledgers are not trustless. You must trust who writes this ledger. Because if after the transfer has occurred, okay, and the one who controls the ledger change this number and write something else, then this is the reality. It's like rewriting the history, okay? It's like the history has been changed. So remember this particular difference, because this is the problem that we have in the digital world. This is the big problem that we have in the digital world. Of course, in our world, this is the way that the things have been addressed, because it's not possible to go around always with the physical money. Okay, I cannot go around with all my money. Okay, and so what happens is that people put money in some places, and when they want to exchange money, Okay, so they put money in some spaces, and when they want to exchange money, this with this, they don't do directly often, but they ask to write something in this authority, and the authority change the amount that one person has and the other person has. This is the current organization of the system, of course. Then, this is good or not? Let's make a little critic, okay? These are the pros and the cons. The pros are very evident because you don't need to go around with the cash. People can easily exchange money and value just asking the banks to change the things, and I think that many people are okay with this. There is no problem, okay, in many cases, okay. But there are some aspects, okay. Remember that the purpose is to implement this in the digital world. So we are looking at which are the pros and cons because we are choosing how to implement this money. And what we see is that depending on where you live, maybe the things are not so good, okay? Maybe this idea of using a ledger and putting the money in some place and not having control on the asset may be not so positive, okay? I'm just make a compilation of the problems. Of course, they happen less or more in some places, okay? You can have, for example, unlimited money printing, okay? This is a bill of Zimbabwe, and you have this bill, which is, I don't know if you can read it. This is a bill of 100 trillion Zimbabwe dollars, okay? As you can imagine, if the government needs to print a billion of $1 trillion, it means that $1 of Zimbabwe is not so valuable, okay? Something happened, okay? I don't want to investigate, but maybe that the inflation, maybe that unlimited money printing can be a problem, okay? And this happens because, of course, if you say that someone is responsible for organizing the ledgers, of course, it's also responsible for the monetary policy, and of course, anything can happen, okay? Because you can just change a number and change the amount that someone has, okay? Other problem, this as a consequence can be negative interest rates, so people are forced to take risks, okay? They are forced to invest in strange stuff because they want more interest, because if they leave the money without moving, the money lose value year after year. So they try to take risks in stocks, etc., to try to save money for the future, okay? Another problem is more political, maybe that you live in some country and you cannot go away from this country with your money, okay? So the capital controls. You say, no, you cannot take money from the bank, you must stay in this country, okay? And you cannot do anything about this because the money are in the ledgers, okay? Many people, I don't know if you know this, but many people don't even have the access to banking. It's the problem of unbanked. There are people that in some countries that to open a bank account must have some requirements, okay? And they don't meet this requirement. They are not able, okay, to access the banking system. This means that they cannot access to the exchange of value, okay? It's they are cut off from the exchange of value, and this is a problem, as you can imagine. This happens less or more in some countries. Okay, now we'll see the pros and cons, but we want to go directly to the digital world because remember, we want to implement this in the digital world. How is the situation if we want to implement this in the digital, for the digital asset? Okay, remember that we have the problem of the double spending. Remember, okay, we have not physical objects, we have not atoms that we exchange. And so if you think about the choice, the big choice, okay, of the ledger or exchange token, in the case of physical, in the case of digital assets, we must absolutely remove the chance to exchange tokens. Okay, we cannot move information directly, and so we must rely on the ledger. This is the only chance, being able to manage the ledgers, because we don't have the physical properties of the exchange. And this is what happens. And so the easiest solution, the easiest solution would be, okay, do you want to make exchange of digital information? Okay, digital value, okay, use a ledger. Using the ledger with a centralized authority, this centralized authority, okay, will be the one that owns the digital asset. Okay. Imagine that I don't know, if you have an image, when Bob wants to transfer to Lisa, then he doesn't have the image. Okay, it's like the image is here, and first it was accessible by someone, then is accessible from another one, and there is a ledger when you write the amount of this value is this. Okay, so there is a centralized authority that manipulates this digital information, and this is the only way to do that. Okay, because we cannot exchange the value directly, we must use the ledger. And using centralized ledger, of course, solves the problem of double spending. Okay, we need a centralized authority. We have no problems. We have no problems? No, we have a lot of problems, because we have the same problems that we have seen, okay, in the physical world, okay, but the particular features of internet make even worse. As you can imagine, centralized and internet are not words that they agree very much. Okay, the same nature of internet is the decentralization. Okay, for example, you can have, if you make centralized in internet, it would be a single point of failure. Okay, so maybe you have this big server. Okay, when you have this ledger, okay, if the server goes down, the system stops working. Okay, you must imagine that having the problem is even worse than in the physical world, because if you have a bank somewhere, okay, physical bank, and you put the things in the bank, a physical attack must go there and take, for example, your gold and put away. In the digital realm of internet, you can have your server here, and you see that at some point, I don't know, at 3 o'clock in the night, when nobody which is responsible for looking at this is sleeping, okay, that you have an attack, a coordinated attack of automated bots that from all the part of the world, okay, go and directly perform an attack toward this particular server. Okay? You can have people that don't even know each other that simultaneously attack a single point from very different parts of the world. So it's even worse than going to a physical bank. And then you have also the problem that you can impose restrictions, you can censor transaction. Imagine you have this point of control, you have just to change a file and change the numbers. You can change the rules, Okay, you can say, no, there is, this never happened, this happened in a different way. Also, you can alter the amount of digital asset because there is no replication cost. Okay, in the digital world, if you are malicious and you are the one that owns the central point of the ledger, okay, you can just put at 0. You say the total amount that we have is of the in the world is 10,000. You go there, you change, you put a 0 here. No, the total that we have is 1,100. Just adding a single digit. There is no replication cost. Okay, it's not like trying to fake the printing for fake money, for example, something like that is even easier. Okay, and even all these things are good, even if you don't have all these problems. The problem is that internet is worldwide entity. Okay, so maybe how do we maybe that we don't have anyone that we all trust, okay, crossing the national borders. Okay, we don't have a single entity that we can trust because internet is worldwide and cross borders for definition. Okay, so centralized is not the solution, and this is all the motivation that is pointing us toward what happened in 2009. So we must revise the question first, and the initial question that we made, and ask to ourselves: is it possible to represent and transfer, okay, purely digital assets, okay, without requiring a centralized authority? Okay, without requiring centralized authority. Is it possible that a set of entities agree on some digital reality, okay, without trusting each other? This is the key point, okay? So we don't have a centralized authority, so the different actors that we have don't have someone they trust. And we don't want someone to trust because for the problems that we have seen with digital assets, which are even worse than the problem that we have in the physical world. But the other feature is also that, so we don't trust, yeah. But we I say a set of entities that want to participate to this problem don't trust each other, okay? So it's even possible in every moment that one of these nodes is malicious, okay, wants to do something bad, okay? We don't trust each other, but we want to be able to agree some digital reality, something that represents the current status of the world, of this digital world that we are going to build. So this is just, okay, the first comparison. It's a very crude comparison, but I want to just put the slide one side by side to highlight the difference. We don't want that people exchange values, but using some centralized nodes that act as coordinator of the ledgers. Okay, these coordinators of the ledger, in which they must trust. Okay, because the yellow one must trust here to the red one. Okay, we want that a distributed network of nodes. Okay, here you read computers, but let's try to be more general. We have nodes, entities, because as we will see, these will be even, I don't know, IoT sensors. Okay, it's not a person, it's not a computer. Maybe a person, maybe a computer, maybe a sensor of temperature. Okay, How can it be that a set of entities can exchange, can agree on some of the current reality? They say, okay, in this moment, the situation is this. We exchanged value, we exchanged information, okay? But everyone, without trusting each other, agree on the current situation, okay? And what happened, the transactions of value, of information, is unmutable. But is unmutable not because you have a centralized authority that guarantees that no one will change the history. It's unmutable because of the way the system works, okay? In the blockchain system, we will see that the immutability is a consequence of mathematical reality, okay? And what is more, is there something which is more, I say, that require less trust and is more beautiful than math? Okay, you can say it's like a reality, math, and you cannot cheat with the math, okay? And this is what will give us the gift of agreeing on this reality, okay? This is the direct comparison, okay? This is the snapshot of what has been achieved with the blockchain, okay? But I wanted to, it must be clear that the path that, so that we arrived at this point must be justified, okay? Because if I start directly to say that we want to a distributed system, you don't understand why, for the exchange of value, this makes sense, okay? So reaching this kind of goal is some kind of discussion and thinking that has been around for centuries, okay? It's not something that it's just a news, okay? The problem is, the good news is that now we have the technology and the knowledge to implement this, okay? Okay, when I say these nodes must agree on some reality, I want to make an analogy. Imagine two people that are playing chess, okay? On what they need to agree, okay? To play the game, okay? They must start from some, they have some starting initial position on the board, okay? And then they, every time they make a move, okay, they can annotate the move, okay? And the sequence of messages that they exchange, the move, which is the transcript of the game, okay? It's something that allows you to reconstruct the state of the board. So you start from the beginning. You say the sequence of moves. And if you follow the sequence of moves, anyone watching the match can reconstruct the state of the keyboard. So this is just to say that if we agree on history, in this case, the sequence of moves, and if we start from a common starting point, then as a consequence, we agree on the present state of the world, which is the digital situation in this case. So we must start from a point and agree on the sequence of the events, okay? So that in any moment is possible to reconstruct the present. Blockchain. Okay, let's start investigating how something like that should work. First of all the entities, okay, as you can see in these slides, it's very clear that they can be very heterogeneous, okay? We will see what is the common aspect that they all must have, okay? So a computer or a sensor of someone, a human being, they must have in common something that we explain later. But in general, a set of nodes, a set of entities, first must agree of initial state of the system, okay? This is called the Genesis block. The Genesis block, there is only one Genesis block for each blockchain. If you consider the main blockchain of the world, which is Bitcoin, you have only one Genesis block. The Genesis block was mined on 3rd January 2009. You can see on the network. You see there, and we will discuss this later because it's very fascinating story because there is also a hidden message inside. After this Genesis block, you have other blocks. Each block here, that you can see here, inside contains some events, something that happened, okay? But in this moment, just to be more simple, just imagine them as transaction of value. So when I say a block contains events, just imagine something like a block contains Alice give 3 Bitcoin, for example, to Bob. Charles gives 1 to Dave. I know some transfer on the. So the transfer are the events, okay? But every time it should be clear that I make the examples with the transfer, Alice, Bob, transfer this number of value. But imagine, okay, if you remember the example of the exchange of packets, this is the base layer, okay? This is the simplest example of transfer, okay? The simple transfer, you can imagine if I have 7 something, I give 3 of these 7 to someone else, okay? To make this example it make no sense to make complicated the inside of the block. So imagine this block, each of these blocks contains several of these transactions of value, okay? So all the transactions that are in a block, it's like they are grouped in this block and they are like part of the same block. They belong to that block, okay? The block is like a timestamp. It happened this block. In this block, you see this reality update, okay? So we have a sequence of block, okay? So just to recap, we have in each block contains events, okay? We have seen the sequence of block, because each block is chained to the next one and to the previous one. Of course, the sequence of blocks represents the history of events, okay? Because if you start from the Genesis block and you look at the different blocks, you see what happened in this digital history, okay? So if all the nodes, all the entities agree on some initial state, which is represented by the Genesis block, okay? The Genesis block usually doesn't contain nothing. It's like, okay, it's empty and says nothing, okay? Nothing happened. Then you concatenate the second, okay? It's like the big bang of the reality, of the digital reality of blockchain, okay? You can see in this philosophical way. If they agree on the sequence of the blocks, they agree on the current state of the system. Remember the analogy with the chess, okay? So if they agree on the sequence, you can say that in this moment, the reality is this, because you have seen all this history happen, okay? You can see that Bob this gives to this, that Bob has no more Bitcoin because I've given everything to that one, etc., etc. But, and I think we will make a break after this slide. This maybe is an impossible mission. It's an impossible mission, I ask to you. Which problem do we have? I think that we have three major problems, and this will be the problem that we are going to solve by going deeper into the internal working of the blockchain. First, you have a block of events, okay? Sorry, you have a block of transaction, okay? But we must agree on the order of the events, okay? It will be better to put here blocks, okay? We must agree on the order of the blocks. We must agree, okay? When I say we, I say that a set of different sensors, people, computers, I don't know what else, beautiful, must agree on the order of these blocks. This happened before this, okay? And remember, there is no global clock. There is no global time. Clock, time, the same, okay? Because trusting in a clock that you see, okay, it will be like having a trusted centralized authority. Because if someone changed the clock, it changed the way that people understand the things, okay? So this is very important. Agreeing on the order of blocks, of the blocks that collect the transaction, it's very difficult if you don't have a global clock. How can you say that the time is going on? Okay, you don't, and you cannot convince the other people that the clock of your computer is the best clock. Don't think about, yes, but each computer has a clock, I can use my clock to, etc., etc. No. Okay. Second problem, we must ensure that the sender and the receiver, okay, that they don't know each other, are the correct ones. So how can I be sure that if I send this and I send something, sorry, I make the example with this one, okay. If I put something in the blockchain in this block here, because I want that this will be received by this one. How can I be sure that only that one will be able to take that value? Because everyone is looking at the blockchain. How can be the destination sure that I will be the one that will receive the data? Okay. Okay. We don't trust each other, so don't tell something. Okay, but they can put in some shared drive that they see both. No, they don't share it. They don't share anything. They don't see anything. They don't trust each other. Okay. They don't know who is on the other side. Okay. In general, the problem that I want to summarize with this single sentence is that entities not trusting each other, okay, without using a centralized authority, so in a decentralized environment, okay, they must agree on some digital reality, okay. So it's very fascinating if you think about this, because you have that if we achieve this this final goal, it's if all these think that this is what really happened, okay, and nobody can change the history of what happened, and nobody is responsible for maintaining the truth of this, And this is immutable because no one is the one that can change what happened. Then we have created some sort of digital reality. And then we can have that different actors for different purposes can use this layer as a platform of trust on which they can build higher level services. Okay, as we can see in the second part of the next meeting, you can replace some notary services. You can say this is true because this was true in that moment. Okay, and nobody can say this is not true because they all agree on this digital reality. Okay, this is what we want to achieve with the blockchain, and I think it will be very interesting to investigate each of these points. If you don't have clear that this is the purpose, you will always think about the blockchain just like a distributed database. Okay, and there is nothing more terrible to go to a meeting and listen to these two words. This is our private blockchain. Private blockchain, if you understand this, it's completely nonsense, okay? I think we can make a breakdown because going forward, because we will begin another section. If you have question, you can